Let's explore context-sensitive grammars, also known as Type-1 grammars, within the theory of computation. We will be discussing context-sensitive languages and their formal properties. A context-sensitive grammar is defined as a grammar in which every production rule has the form alpha. A beta produces alpha, gamma, beta. Here, the length of gamma is greater than or equal to 1, and A is a non-terminal symbol. This means that the replacement of a non-terminal A depends on the context provided by alpha and beta, and the production must be length non-decreasing. Context-sensitive grammars possess two key properties. First, they are length non-decreasing, meaning the length of the strings never decreases during derivation. Formally, the absolute value of alpha is less than or equal to the absolute value of beta for every step alpha derives beta. Second, the production rules depend on the surrounding context of non-terminals. In the rule alpha, A beta produces alpha, gamma, beta. The context alpha and beta is preserved. A classic example of a context-sensitive language is L, which consists of strings with an equal number of A's, B's, and C's in that specific order. Formally, L is defined as the set of A to the power n, B to the power n, C to the power n, such that n is greater than or equal to 1. Here are the grammar rules for the language L, where L equals the set of A to the power n, B to the power n, C to the power n, such that n is greater than or equal to 1. The production rules are as follows. S produces A, S, B, C or A, B, C. CB produces B, C. BB produces BB. Within the Chomsky hierarchy, context-sensitive grammars are classified as Type 1. Type 0 grammars are unrestricted and generate recursively enumerable languages. Type 2 grammars are context-free, with productions in the form A produces alpha. Type 3 grammars are regular, representing linear grammars. The machine model equivalent to context-sensitive languages is the Linear Bounded Automaton. A linear bounded automaton is a Turing machine with a bounded tape, meaning the tape length is less than or equal to C times the absolute value of the input. Therefore, context-sensitive languages are equivalent to LBA recognizable languages. Context-sensitive languages exhibit specific closure properties. They are closed under both union and intersection, but not closed under complement. They are closed under concatenation but not closed under the Kleene star operation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.